Hi, thanks for stopping by. In this video, we're going to talk about graphical or G-Airmets. As mentioned in another video, we discussed textual airmets and how the FAA and the National Weather Service plan to discontinue those textural products. Back in the early 2000s, I think it was 2006, the National Weather Service transitioned over to graphical airmets. They started taking airmets in the textual form and from that producing graphics, in other words, weather maps that show the hazards. And so that's what a G-Airmet is. It's simply a graphical representation of the airmet, and it gives you a little bit better idea of where weather hazards are located. Not only that, but also their areas are smaller than the textual. The textual product puts out a 6-hour forecast. G-Airmets are a 3-hour forecast, so they usually cover a smaller area. So with a 6-hour forecast, it covers a large area because it has to look at the entire movement of the weather system across that area over those 6 hours. If you look at a 3-hour forecast, then more or less it breaks that area down into more or less half. So it'll give you a much smaller area for a forecast for turbulence or icing or whatever. So here are the elements that are included, or the criteria for graphical airmets. Of course, it covers moderate turbulence from the surface to 45, surface sustained winds of more than 30 knots, low level wind shear, which is plus or minus 10 knots of change below 2,000 feet. Surface visibilities less than 3 miles, which would be IFR, and ceilings less than 1,000 feet. And then also to give you the cause of the surface visibility restriction. Also included in the graphical airmet is icing, freezing level, multiple freezing levels, mountain obscurations, and the cause of the mountain obscuration. You can find graphical airmets at the Aviation Weather Center under the Advisories tab. If you pull down the menu, you'll find a link to G-Airmet. And this is what you'll see when you get to that site. You'll see a lot of weather hazards across the United States depending upon the type of weather that's occurring. In the summertime, a lot of times there's not a lot of hazardous weather except for thunderstorms, of course. But however, in the wintertime, you'll see a lot of IFR, turbulence, low-level wind shear, and icing. There are a couple areas that you can click on. The first, of course, you see right away is all the hazards, and it gives you a general overview. However, if you go down to the corner or down to the bottom, you'll see the G-Airmet plots where you can plot each individual airmet and it won't be so messy. Or you can look at G-Airmet thumbnails, which are really handy also. At the top, you will have a menu bar, and there you can click on the type of hazard that you want to see. You can lay them all on top of each other, or individually you can look at each one by itself. And then also there is a time slider that shows you into the future the weather hazards and how they change and how they move. At the bottom there is a legend, so it will help you interpret the symbols that they put in the G-Airmet. The G-Airmet for IFR weather, of course, includes areas where ceilings are less than 1,000 feet and or visibilities are less than 3 miles. As well as mountain obscurations. Those are plotted separately, and they outline those areas. Mountain obscurations are where areas where mountains are hidden by clouds or precipitation. Moderate turbulence is also plotted. They plot non-convective, and they show either low altitude or high altitude. They separate those so it's easier to see if you're flying at low altitudes or high altitudes. Low altitude would be from the surface up to 18,000 feet, and high altitude turbulence would be anything from flight level 180 to flight level 450. They show symbols for the turbulence. Now remember that the forecast is for moderate turbulence, so you can see the symbol is only one hat. And they give you the base of the layer and the top of the layer. In the first image, you can see that the base is the surface, whatever the elevation is at that altitude or that location. And then they show you the top of the turbulence. It goes up to 17,000 feet. And within that layer, you can find moderate turbulence. The picture or the graphic at the bottom shows higher level turbulence going from flight level 200 up to flight level 380. And of course, the symbol tells you that it's moderate turbulence. Non-convective low-level wind shear is also plotted. This is where pilots can expect a change in airspeed of 20 knots or more near the surface, below 2,000 feet AGL. So this is close to the ground. If you're taking off or landing, wind shear tends to be hazardous, especially large changes over a very short distance, and they will plot that. Also, they show areas where the sustained surface winds are greater than 30 knots. These are not the gusts, but sustained winds. So the average wind, if it's more than 30 knots, they'll highlight that area because that could be hazardous for aircraft. They also show areas of moderate icing. This icing is not in convective clouds, not in cumulus, so they're just forecasting not in thunderstorms, basically. They show the icing layer. They show you the base and the top. In the first image that you see, it shows an area of icing from flight level 180 to flight level 240, and that symbol represents moderate icing. If you have two numbers like you see at the bottom there, surface or 9,000 / surface, that tells you over that area the freezing level varies, or the icing level, start of the icing varies from the surface to 9,000 feet, more than likely because of a change in freezing level across that area. And then you can also see that on the other image that shows the East Coast, where the freezing level starts somewhere between 5,000 and 11,000 feet, and that's where the first icing can be expected as you climb out, with tops at 24,000 feet. They also show the freezing level. This is the lowest altitude at which 0 degrees Celsius is encountered as you climb. Remember that these are always MSL altitudes, and on this chart they give you increments of 4,000 feet. In other words, they will plot the freezing levels at the surface at 4,000, 8,000, 12,000, 16,000, and so on and so forth up. Yeah, the symbols, the first graphic shows the symbols that they use. They use a line with little hairs on it, and they have a legend that says 0 and then a colon, and 120 or 040 or 080, which tells you the altitude of that freezing level. It makes it a little bit difficult. You have to look at that label and then follow the arrow to the particular freezing level line. And then also, if there are multiple freezing levels above a location, they will highlight those areas and they'll tell you the altitudes of the multiple freezing levels. For example, in the graphic that you see here, they're telling you that there's multiple freezing levels from the surface to 11,000 feet. Here's an example from the Aviation Weather Center, a G-Airmet for turbulence at low altitudes. Here's an example of turbulence at high altitudes above 18,000 feet. Here is an example of areas of low-level wind shear where pilots can experience changes in indicated airspeed of more than 20 knots within 2,000 feet of the ground. Here are areas where the sustained surface winds are greater than 30 knots. This is a G-Airmet for IFR conditions, both precipitation, mist, fog, and blowing snow. Here is a G-Airmet for mountain obscurations. This is a G-Airmet for moderate icing, showing you the tops of the icing levels and also the bases of the icing levels. Here is a G-Airmet showing you the freezing levels from the surface extending up to 16,000 feet, and also areas of multiple freezing levels. That was a quick overview of G-Airmets. I hope you enjoyed the video.